just like we were able to convert polar coordinates into rectangular xy coordinates, we are able to do the same thing with equations. There are polar equations, which we typically see in r equals form, and then there is some theta in the equation. And you can actually graph these equations in your calculator when you are in polar mode and radian mode, and you would get a graph. But we're going to change these equations into rectangular equations, meaning we're going to get the r and the theta out. We're going to convert it to x and y equations, and we're going to see if we recognize it in this rectangular form, which is what we've been always used to. The same conversion equations are going to apply here. So I know if I have an r squared, I could plug in x squared plus y squared, some things like that. So if I got an r squared, that would be great. So what I'm going to do to this equation is I'm going to multiply both sides. I'm going to just multiply both sides by r. So when I multiply this side by r, I get r squared. And when I multiply this side by r, I get a 5r cosine of theta. So now I am looking to get some x's and y's in here. So I see a couple things. One, we talked about r squared is x squared plus y squared. And then we've also seen the equation that x equals r cosine of theta, so I can substitute an x in for this. Now this equation is starting to look a little weird in the xy sense. Whenever I have these x squareds and y squareds in my equation, it might not necessarily be the best to get it in y equals form. These are ones that usually turn out to be circles or ellipses or things like that. Because there's no division here, I am thinking a circle. Remember, a circle's equation is that x minus h squared plus y minus k squared equals r squared. So I might try and that x squared. If I bring this 5x over, then I have a plus y squared. Right now this equals 0. Now this is going to require a little bit of manipulating. The y squared is kind of on its own. That tells me the k is a 0. So I'm just going to have a y squared for that piece. But this piece, I'm wondering if I can make it into some type of quantity squared. In order to do that, I'm going to need to complete the square. So I'm going to ignore the y squared for right now. I'm going to try to just complete the square with this piece. So if it's a minus 5, this is a tricky completing the square, I'm going to take my b over 2, which is 5 over 2, and I'm going to square that, which is going to be 25 fourths. So I'm going to add that 25 fourths to both sides. What happens is this piece here is a perfect square that I can factor into x minus 5 over 2 quantity squared. So I just did a little completing the square right here with my x's to make it more in the circle format. Plus y squared equals 25 fourths. So this is a circle, center is at 5 halves 0, radius is 5 halves. So that circle is what should actually graph if you were in polar mode and you actually graphed this 5 cosine of theta. So some interesting things that we'll be able to look back and forth at those modes with. Let's try another. This one's actually also pretty similar. I see this r equals, we've got 2 thetas over here. I might, again, try to get an r squared. So if I multiply both sides by r, I get r squared equals, this is a 4r cosine of theta minus a 4r sine of theta. So I've got an x squared plus y squared equals 4x minus 4y. Again, another x squared and y squared equation, so I might just leave those on the same side. If I bring over my x term, I'm already thinking like the last one, we completed the square, so I might leave a little blank here. And then I have my y squared plus 4y, and I might leave a little blank here to complete the square. And then right now this equals 0. So if I'd like to get this in that nice circle format, I'm going to complete the square with my x's so that I can change it into that quantity squared. So here, if I complete the square, I'd be having 4, squaring it, which is 4, adding that to both sides. Having this, squaring it, it's actually 4 again. So this is looking like an x minus 2 squared, plus this one is a y plus 2 squared, equals 8. So I've got a circle at 2, negative 2, radius of square root of 8, which is 2 radical 2. So this is, again, another circle. But those are a couple examples of converting polar equations into rectangular ones. Again, manipulate your equations so you can use those conversions. It doesn't always turn out like this. I think these are a little bit harder than some of the others, so I wanted to show you some of these circles and completing the square ones.